We'll practice using time dilation to find the lifetime of a fast-moving muon and the distance it travels. Here's the problem. A muon travels through the atmosphere at 0.98 times the speed of light. Its proper lifetime measured in its rest frame is 2.2 microseconds. Part A. Find the muon's lifetime as measured in Earth's reference frame. Part B. Find the distance it travels in Earth's frame during that lifetime. First, we compute the Lorentz factor gamma using the formula gamma equals 1 over the square root of 1 minus v squared over c squared. Gamma equals 1 over the square root of 1 minus v squared over c squared. V over c is 0.98, so v squared over c squared is 0.9604. 1 minus that is 0.0396. The square root of 0.0396 is about 0.199, and 1 over that is approximately 5.03. Now we apply time dilation. The dilated lifetime in Earth's frame is gamma times the proper lifetime. Delta t equals gamma times delta t naught. 5.03 times 2.2 times 10 to the minus 6 gives 1.11 times 10 to the minus 5 seconds, which is 11.1 microseconds. Finally, we find the distance traveled in Earth's frame using distance equals speed times time. D equals v times delta t. V is 0.98 times 3.0 times 10 to the 8, which is 2.94 times 10 to the 8 meters per second. Multiplied by delta t, 1.11 times 10 to the minus 5 seconds, gives 3.3 times 10 to the 3 meters. The key idea is that time dilation causes a moving clock to run slower, so the muon's lifetime appears longer in Earth's frame, allowing it to travel farther than its proper lifetime would suggest.